Welcome to our meetup for the month of June. We have a tech talk about how to increase your database change success with DBmarlin and Liquibase. Before we get started, we're going to go ahead and go over our agenda. We cover why we're here, our code of conduct, introductions, and then we'll get started with the presentation. Why are we here? Well, we're here to meet each other, learn something about Liquibase, and at today's presentation, something about DBmarlin. And we're going to ask questions, share problems, any other information or insights that we have. So without too much further ado, I'll hand it back over to myself, and then myself will hand it off to Russ and Mick. Thanks. Challenges that we're facing and help to support each other in the community. And we are welcoming to everyone here, so please keep that in mind and be respectful. So here is the instructions for changing your little screen name. It doesn't change it permanently, it's just for this meeting. If you want to change it to your first name, your country, and your role, so we can get an idea of who we're talking to and get to know y'all a little bit. And then it's DBmarlin's turn. So we have Mick.
Yep. Hi, everybody. Let me just get the right screen up and then I can start sharing. Share desktop one. Okay, right. If we can see a DBmarlin logo.
Yes.
Excellent. Okay. So, good afternoon, good morning to everybody. Thanks for having us present on the meetup. And so what I'm going to show to you today is a short demonstration of DBmarlin, and so you've got a better understanding of what it does, and then how that then fits with Liquibase. So there is an integration, which I'll show you as well. So yeah, just to kind of kick off things, I thought we'd start off by explaining a little bit about what DBmarlin actually is. I guess most of you are probably not familiar with it. It's a fairly new, it's been around for a couple of years now, but a fairly new database performance monitoring tool. And so the problem that we're trying to solve is this one, as highlighted by this Gartner statement here, which is that 85% of production issues are caused by change. So if you had a completely static system, you probably also have a lot fewer production issues as well, but we know that's not the way the world works, and applications and databases are always undergoing continual change, and so this is where DBmarlin is trying to help protect database performance in a changing world. So we designed the product from the outset as something that could give both performance of your databases, but also change information as well. And so we pull in change information where we can kind of see it for ourselves, but then we also like to pull in other sources of change information which we might not be aware of, and that's where things like Liquibase come into the picture. So thinking about the different roles, I guess a lot of you on the call will probably fall into one of these categories, but these are the types of roles that are primarily interested in database performance and also database change. And so bringing those two things together, I think is applicable to a lot of these. And these days, it's not just database administrators, although database administrators are still a kind of vital role in terms of applying change to the database, patching the database, upgrading the database, making schema changes, tuning parameters. And anytime you do any of those things, you want to know what was the impact on database performance. Did it get better? Did it get worse? Did it stay the same? But then you've got other roles as well. So managers who might just want to have a kind of high level overview of performance. You've got developers, which are obviously really important, who may be interested in just how their particular database statements are running. Are my queries getting faster or slower? And if they're getting slower, how do I tune them? So that's a big role. Then you've got DevOps engineers, which are looking at kind of automating processes, continuous integration, continuous delivery, and how you can automate that whole process. So there you're applying changes on a much more regular basis than used to be the case. And obviously any one of those changes can have an impact on performance. So that's where you really need to close the loop to bring together your performance monitoring and your change into a single view of the world. And then you can actually start to see, did this change have an impact on performance? If so, what am I going to do? Can I roll back quickly? Can I remediate the problem and fix and move forwards? And then some other roles as well. So performance testing, any time you put in load through a database, you want to see whether things got better or worse and compare previous load tests with the current load test. That's another good use case for using us. And then site reliability engineers who just want to improve performance across the board for their applications and their users. And obviously database performance is a big part of overall application performance. So how DBmarlin helps with this, we can spot problems early in the life cycle, development and test. So we can try and spot those things before they reach production. Obviously, some database problems will always get through to production. That's just the way the world is. Because usually production is the only place where you have the traffic volumes and you have the data volumes where those performance problems will manifest themselves. So as much as you try to do in dev and test, there will always be some that get through to production, and then it's really about how quickly you can respond to those. DBmarlin is going to help you understand the impact of those performance, the impact of your changes. And ultimately, it's going to help you release with greater confidence. So it's going to mean things are less stressful. It's going to save you time. And hopefully of interest for everybody on this meetup in particular is the fact that it integrates with Liquibase, which I'll show when we get onto the demo. So some of the benefits of the integration is bringing Liquibase changes into DBmarlin. So you've got that performance and change all in one place. You've now got the context of your changes. We have the ability to snapshot performance before and after. I'll show this in the demo, and then you can start to then see how performance compares before and after any kind of change. So yeah, by combining the two products, DBmarlin and Liquibase is going to help you safeguard performance and reduce your risk. And at the bottom there, you can see a nice quote from Andre, who's on the call. I guess Andre can probably speak for himself later at the end of the presentation, but it's really great to have Liquibase actually using DBmarlin themselves internally to monitor some of their databases, in particular the databases behind the hub, which some of you will be using. So I'm going to jump over into my demo environment now. I'm just going to give you a quick tour through DBmarlin so you can see what it looks like and the kind of information it gives you. And I'm going to show you how it integrates with Liquibase as well. And I'll show you how you can do some of these things that will help you analyze performance before and after a change. So the snapshots feature and our comparison reports. So if I jump over into this window here, I might just go full screen for this. So the top level screen within DBmarlin, you can see here, it's straight away from the start, performance and change. It's right there at the top of the screen. Like I said, we architected the product from the start to bring these two things together. And you can see it here then in the tabular view. This is a list of all the database instances we're monitoring, and as well as the performance KPIs like database time, number of executions, average SQL response time. We have a column here which says changes, and you can see this had 8 changes, this had 4 changes within the time range we're looking at. So those changes can be things that we auto detect for ourselves. So we have a change detection engine which works for schema changes like changes to tables and indexes. But for anything else, we can pull that in through our API, which is the way that the Liquibase integration works. So it's interfacing with our API to tell us about other changes that we didn't auto-detect. And again, because we thought change was such an important thing, we also made it a top level screen here as well. So we have a change history screen. And now you can start to see a bit more detail about when these changes happen. So the orange ones here are the custom events that have come through our API, and the blue ones are the ones that we've auto-detected. And then you can see those in a kind of tabular view down the bottom here. So a couple of these are Liquibase changes, the one at 1501 and the one at 1545. So we can filter that list just to see these two here. And when Liquibase sends us these events through our API, it also includes a hub URL, which is what makes this a clickable link here. So if you wanted to see 1501, what was this change, we can click on it here. It takes us straight into Liquibase hub. And if I log in with the correct user, we'll see when that change set was applied. So we've got more information now about the target database it was applied to, the version of Liquibase and the system that it ran on, the change log, the labels, when it started, when it finished. And in this case, you can see who the change set author was. You can see what the actual SQL was that was executed there and how long that took to run. So in this case, it was a create index statement that took 81 seconds. So we've got that for any of the Liquibase change events. We can click through into the hub there. Now, I guess the big question, as I kind of alluded to in the slide presentation, is what was the impact on performance of these changes? You know, did things get better or worse as a result of that? So with a single click here, we could click through into this Postgres instance here. And now we're looking at an instance dashboard for this particular database instance. And again, we've got the changes at the top level, but you can also now see that we put them overlaid onto the performance chart. So this top chart here is showing us database time, which is the green bars here that you can see. So that's our database time. The orange is the execution count, and then the gray arrows with the annotations here. This is when the changes were applied. And to see what those changes were, we've got the changes tab down here. And again, you can see some of them are auto-detected changes. Some of those are ones that have come through the Liquibase integration. So in this case, the ones at the beginning, it was the Liquibase change that applied 3 new indexes. And then the one 45 minutes past was a second Liquibase change, which then drops those same 3 indexes. And so you can see here at the top of the screen what the impact was on performance. So when the before the indexes were applied, database time was high. Each of these bars is a 1 minute bar. So you've got in that one, for example, 266 seconds worth of database activity within that 1 minute. Then the indexes have been applied and you can see database time drops to be a much lower figure, something like 3 seconds worth of database time here. But you can also see that the orange line, which is the execution count, has increased. So you're actually getting more throughput as a result of that as well. So more executions, but less time. And then what happens over here is the indexes get dropped. That's when the changes are applied here. And then the green bar, which is database time, suddenly increases again. So that's how you can easily relate performance and change together. To take this a few steps further, when you're looking at database performance, the way we approach this is we look at database performance in terms of time. So you start with this overall figure of how much time is spent in the database, and then you start to segment that to see where the time was spent. So a few ways you can break that down on the chart. One of them is by looking at the weights, and different databases will have different weight events. So in this case, it's Postgres. We see the dark red, which is active time. Typically that will be CPU time. And then the other colors here, like the data file read, that's more of an IO weight. And then you've got some buffer mapping, while sync, and various other things here, accounting for small percentages. So that's one way of breaking down time is by weight events. Another way is to break it down is by the statements themselves, to see what the statements were that were contributing to that time. Again, you can see in the colored bar, each of the colored bars represents a single statement. And again, you can see that in this donut chart here. So you've got 1, 2, 3, 4, about five statements that account for the majority of your database time. And then you've got some others that are accounting for smaller percentages there. And then if I go down to the lower half of this screen, this is where we can really start to drill down a lot further by lots of different dimensions here. So if you look across the tabs that you've got at the bottom now, you may want to drill into performance by specific things like the program, for example. In this case, 99% of my activity came from this program. So I might want to click into that. And what that does now is it applies a filter at the top, and then it redraws the screen. So everything that you see now is just the database activity from that one program. And likewise, you could go through some of the other tabs. You could go to the users and say, just show me activity from this user. You could go to the databases and say, okay, 98% of my time is in this database. These are the different databases within that instance now. So I'm just interested in any statements that ran within that database. And you can see at the top now, we've got a list of filters applied. So everything that we see now is just in the context of that. And then you get down to having applied some filters. Usually when you come down to actually doing the tuning or understanding performance, you're looking at these first two tabs. So either looking at it by statement or looking at it by weight, depending on how you're going to approach this tuning. So if you're coming at it from a weights point of view, you want to see where the time's spent. So you've got some active time, data file read, buffer mapping, like we saw earlier. And if you need to understand a bit more about what these actually mean, we have a knowledge base, which you can click through in context. And the knowledge base here will tell you, this is what data file read actually means. It's an IO wait event. This is what you can do to reduce it. And then some links through back, in this case, to Postgres documentation or some other third-party articles on that subject. And we have this knowledge base. It's freely available. Obviously, anybody could access this, but it makes it easier if you're using the product as well, because you've got that click through in context. We have that for over 1,000 different weight events across all these databases here that we're actually supporting. If I go back to here, so one approach, as I said, would be to tune based on weight event. The other approach would be to tune based on trying to optimize some of these statements. So if we go to our statements tab, we can see we've got a number of statements here that contribute most of that database time. So if I click into the top statement here, this is our worst performing statement during this time range. And you can see from the chart at the top, it was obviously impacted by these database changes here. And in fact, it also changed its execution plan as a result of these changes up here. So if I go down to the bottom now, what you've got here is you've got the full statement text and you've got the execution plans tab. And on the execution plans tab, you can see we've actually got two of them. And the way we're able to do this is because we're, rather than just giving you an on-demand execution plan right now, we're actually tracking these over time in the background as part of the monitoring. So you can actually see when something switches its plan. So in this case, you've got two plans. You've got this one here, which has got a cost of 304,000. And you see it's doing a sequential scan on the rates table, and it's doing a sequential scan on the rides table. The rides table in this case is a very large table, which is why the cost is so high. And just like we had with the weight events, we also have a knowledge base link here. So if you want to find out what sequential scan or SEQ scan means in Postgres, you can click here. It takes us into the knowledge base and you see, well, sequential scan means it's going to return all the pages in the table. So it's effectively a full table scan, or yeah, I mean, it's got various different names depending on the type of database that you're used to working with, but yeah, it's effectively got to scan the entire table. So this is obviously at the point where that index has been dropped and it doesn't have any index that it can use. So that's the reason it has to do sequential scan in this case. What you can do is you can then toggle to look at the other plan, which was in effect from this period, which is when that index was then available. You can see in this case, it's still doing a sequential scan on the rates table, but that's a very, very small table. That's just a lookup table, so that's fine. But now it's doing an index scan on the rights table, which is way lower cost than having to do that sequential scan. So that's kind of pulling it all together to understand root cause and getting it into SQL tuning and that kind of thing. A couple of other things I wanted to show. So I mentioned during the slides that we have a feature called snapshots, and we also have a time comparison report. So I just wanted to just take a little bit of time to explain those two things to you. So what we can do here, let me just clear my filters. Just going to go into a different database here just to illustrate this. So if I go into this MySQL database, first of all, you notice if you're looking at a MySQL database, the data looks exactly the same as what you just saw for Postgres. Same would be true if you were looking at Oracle, SQL Server, DB2, Cockroach DB. We give you this exactly the same dashboard across all of them. So that's one of the big things with DBmarlin, having that common consistent UI rather than having to switch between different tools for different database engines. In this case, you can see we've got a spike in database performance here. It lasted for 5 minutes. And if you put on the wait stage, you'll see all that is locking time. So locking is a common problem with databases, common cause of performance problems. So what you could do is you could save a snapshot of that, because this may be an incident and you want to then share that with somebody. You might want to attach it to an incident ticket, or send a Slack message or email or whatever. And what you can do, if you say save snapshot here, we can say MySQL locking incident. If I can type. You don't have to put a description, but then you've got an option here to keep the data as well. If you do the keep data option, that means that this snapshot will then get stored indefinitely. This data will never get rolled up or purged like the rest of the monitoring data. We're going to keep this forever. So if I do that, you can see it says snapshot saved. So let's say I was looking at a different period of time entirely. I was looking at yesterday or whatever, and then I want to get back to looking at that snapshot again. So what I can do now, I can recall that snapshot from the drop down here. So I've got a few snapshots in my list. So this is the one that I've just saved, MySQL locking incident. I can click on here, and you see it pulls back up that same view that we were just looking at here. And these snapshots, like I said, if you go to your snapshot screen, you see as long as you've chosen the option to keep the data, those will get kept for as long as you need them, until you actually then click the delete button here if you no longer need that data saving. So where these are useful, that I've obviously given you an example there of how you might use it in the case of an incident, but you might also use these in the case of a change. So let's say you've just made a change. It could be any type of change, doesn't really matter. You can save a snapshot for the period before the change, save a snapshot for the period after the change, and then we can actually put these into our time comparison report. So the time comparison report is just a way of comparing 2 periods of time for a particular instance. So if we said, let's have a look at Postgres 11 You can also compare across instances. So you could compare with a different instance. Sometimes it makes sense to do that. Maybe if you're doing a database migration, so like you're moving from one database technology to another, you could compare, let's say Oracle database with Cockroach DB or something like that if you needed to. In this case, I'm just going to say compare same instance for two different time ranges. And the way you would normally do this is you would just pick the time period before and you pick the time period after. But now we have the snapshot feature. You could just do it this way. So February the 17th is a snapshot, and February the 16th is a snapshot, February the 17th is a snapshot. And you can just compare them that way. So you've got both options. You either enter the time or you pick a snapshot. And then having done that, you can then say generate reports. And this report is then going to do all the analysis for you. So rather than you having to kind of pull up two windows side by side, one for each period, it's going to do that for you and actually work out the differences. So during this period, database time was this. During this period, database time was that. So that's an increase of 55%. So the database is definitely busier. Has the throughput increase? Yes, slightly. We were doing this many executions, now we're doing this. So we've increased by 19%. And you can start to see then further down what the differences were. So you can look at wait events, you can look at statements, and then you can see statement by statement whether things have got better or worse there. And then right down the bottom, so that this is kind of going back to changes again, we list, in this environment, we get a lot of repeating changes because it's a test instance, but down the bottom of this comparison report, we see changes within the first period, changes within the second period, and then changes in the interim, so between the two periods. In this case, there weren't any because they're two consecutive periods. So yeah, that's the time comparison report, which is really useful. I don't know. I normally show. I have a customer example. I don't think I've got it to hand, but we did a performance engagement with a customer in the US. You can find this on our website. In fact, let me just do that. It's always a good one to show. My Zoom window's getting in the way. If you go to DBmarlin, if you look under customers, Zoom needs to move. So yeah, so if you look under customers and then read this one. So this is Academic Excellence. They're a customer in the US. If you look at this time comparison report here, maybe just zoom it a little. This was a MySQL instance. Before we did any tuning, this is in a 1 hour period on the 28th of May. They had 7 days worth of database time. And then after tuning on the 2nd of June, the same 1 hour period, they had 6 hours. That was a drop of 97%, if you can read that. We also looked at it from a host point of view. You can see the host CPU time was 97% on average over that whole period. You can see it's the red line here. So it was pretty much flat out 100% CPU for the majority of that hour. After the tuning, you can see CPU line, which is the red one, again down here is actually 10%. So and that was in their case quite a large server. I think it's 48 CPU cores, and the reason they were maxing it all out was, you can see the red here is, I might need to zoom that. The red here is basically time spent sorting result. So what they had here was a case where they had a query that was selecting from a very large table. It was just a single table, and it had a where clause with 2 conditions, and condition A would filter it from something like 500 million rows down to 20,000 rows, and then condition 2 would do something similar, but then it had to do a sort merge on the 2 result sets. So sort merging 20,000 rows with another 20 or 30,000 rows, and it was doing that continually, and that's the reason performance was killed. In this case, the one change, there's only one change between these two periods, and that was a single index, which is a combined index on those two columns. And that's the thing there. So they've actually gone from maxing out a 48 core machine to being virtually idle in their case. So yeah, so that was a nice one. You can obviously read more about that if you want to. But yeah, I think as far as demoing, the one thing I haven't shown, which I just remembered, is how you actually set up the integration. So I'll show you that, and then I'll open it up for questions. The integration, the easiest way is, well, I guess first of all, you would probably want to install DBmarlin. Having done that, if you click on documentation and just search here for Liquibase, you'll find the instructions of how to install it. First thing you need to do is download here. The download itself is on GitHub, and it's just this jar file that you need here. So you can either just download the jar file and stick it into your Liquibase lib directory, or I was told earlier by Derek, which I didn't know, is you can also use the Liquibase package manager. So if you use LPM and then do add DBmarlin _ extension, that will also do this automatically for you and pull this down, stick it in your lib directory. And then as far as configuration, really, there's just a couple of extra things that you want to put into your Liquibase properties file. So the DBmarlin URL and the DBmarlin instance ID are the two things that you need to add there. So fairly simple setup. If you want to any assistance with this, you know, we can obviously help you if you've got any trouble getting installed, but hopefully it should be fairly straightforward. So yeah, I'm going to leave it there and pass back over to see if there's any questions. Thanks, Karen, for the putting the links in the chat window as well. So those are the GitHub links there.
All right, so let me pull up my screen here. Oh, we did our handoff.
Andre, I was curious, could you share a little bit of your experience getting DBmarlin and Liquibase set up, and then anything that you have just, I know you're our SRE, so you pay attention to Hub and make sure that we have good uptime, but I was just kind of curious to hear what your experience was like.
Yeah, it actually was a very good experience. So just a little context, I had spent a fair amount of time sort of building a monitoring stack using various tools, as a sort of a DIY approach, and it was very useful. They were pulling together a lot of things, but the database layer is hard to monitor. You have to kind of know a lot about what is a normal SQL query versus not a normal SQL query. What's, you know, there's just a lot of metrics to monitor. And when I was told about DBmarlin as a sort of a package solution that gives you all that out of the box, we were pretty excited about it. So I started to look at how to set it up and found that the installation process was really pretty easy. So I took that sort of documented installation process and turned it into an infrastructure as code template, because all of our server images are automated. So I was very easily able to convert the instructions I read to this installation code. And so we spun up a server, like, you know, within a couple of hours that had a DBmarlin instance running. In our case, it's all nice and sandboxed and private. So I wasn't too worried. I didn't have to implement a lot of security around it because we had the environment providing that. But once I had DBmarlin there, I just pointed at our Hub databases, and lo and behold, we had really nice visualizations of you know, the performance of our Hub databases, something that would have taken me like days and weeks to implement in our DIY stack. So that was a big win, you know, lots of bang for very little time spent. And I'm very excited to see how it's been extended with the Liquibase integration, with the snapshots and the time comparison view. You know, and what really struck me is that sort of the UI is really very well thought out. It's very modern data science UI, you know, with lots of time histogram view is very intuitive. It has a lot of filtering there, and then you can aggregate. It does the aggregations that you want to see sort of right out of the box. So again, it saved me a lot of time having to reinvent the wheel. Yeah, so my experience was really good, and I'm looking forward to extending that to other databases. And in fact, I had a question for Mick and Russell at some point about that. So.
Yeah, sounds good.
You can go ahead and ask now if you want.
Yeah, actually, your talk was very inspiring there. And my question is, so do you have a way to automatically add the monitored instances or that monitored databases to an existing DBmarlin server? So I've set up the server and I want to make an API call to it to say, here's a database you want to monitor, and then here's a database I no longer want to monitor. You can add it and remove it.
You can, yeah. So the API allows for that. And that is something that's actually been requested more and more. So people have these kind of concepts of throwaway databases where you spin something up for a short period for testing and then destroy it at the end, and you want your monitoring to kind of be automated alongside that. So yes, it's certainly possible. I can send you the API because our API isn't well documented at the moment. It is about to have a open API kind of Swagger interface to it. That's coming in 2.6 end of this month. But yeah, right now I can send you some API calls to do that.
That's great. Yeah, I mean, it was exactly what you were saying, and I was thinking maybe there's a way we can link this into our test harness or other things where we can give devs the ability to monitor the databases that they're testing. So, thank you.
Yep.
Does anybody else have any questions?
Not a question so much as a comment. This is something I find a lot in database tuning, is that developers who don't necessarily understand databases really well tend to put a lot of single column indexes on. And that was an example that Mick was talking about there, that they think that if they create a single column index on this one, and a single column there, and do a where column A equals and column B equals, that somehow the results of those indexes will be magically merged together. So yeah, often the multi-column index is the solution, and also therefore you end up with an over-indexed database. So sometimes adding an index is a good thing, but also from an inserts perspective, dropping indexes is a good thing. So that would be a good use case there. So hopefully not in production, but if you try it in a realistic test system and you drop indexes that you don't think are being used, and performance will either go south or it'll be fine, in which case you can confirm the index to be safely dropped.
Yeah, definitely. Good point. Yeah, dropping of indexes is something that a lot of people don't do because they worry that there could be a performance impact as a result of it. But yeah, definitely the point about single column indexes, sometimes you can't combine them, or the actual operation of combining data from one index and another is expensive. Sort merge, sorting is particularly expensive on CPU time, like you saw in that example. So
yeah, Alistair, it's a really great point. I love the idea of being able to shift things left and move it over to development time and not production time. And I love the fact that you can compare different snapshots in time, and you can see what your performance impact is before you actually push to production. And I guess if it made it to production, you could still compare it and quickly go make a change. So maybe take some of the fear out of dropping indexes where it really is a good idea. Cool. Daryl, did you have any thoughts or feedback or ideas?
I don't think so. It looks really good. I like the tool and the graphing. Good job.
All right.
It's the first time I've seen the tool, so.
Yeah. We've just started using it. It's been a few months, I guess, now, but obviously you hear Andre is ready to shift it left and get it not just as a production tool and move it over to development to try to start catching some of these things earlier, which is always the goal. So yeah, it's exciting. We're enjoying using it for sure. And it's nice having the time with Liquibase so we can see, we have so many people working on it together that people can figure out what, kind of root cause analysis, who made the change that impacted the database. It's real easy to figure it out and quickly go make an update and fix it. So it just makes it easier for the team to work together and do so with a lot less risk than we had in the past.
Go ahead.
I was just going to say, I see a big opportunity, sort of a pedagogical opportunity for DBAs to sort of educate devs and other technical stakeholders about complexities around databases, because a DBA who previously would have to sort of explain things in very arcane ways can now very visually say, here's, what a change in a database does, and you can see it, and you can see it play out. And I think that shouldn't be underestimated. It really helps communication within the organization as well. So.
Yeah, communication is a big one. Yeah, if you can get everybody using this, all the different roles that I showed on that slide, if everybody's using it as a means of communication, then yeah, it definitely helps.
Excellent.
Yeah,
Ken?
awesome.
I'm just going to check with the rest of the people on the call and just see if anybody had any other questions or thoughts. Ken, did you have any feedback or ideas?
No, not right now. Thank you.
Excellent. Did you find it useful? Is that something you think your teams would be able to get value from?
Yes, I did. And I think they would. They have some other database monitoring tools in place already. So I'm not sure how interested they'll be right now, but.
Fair enough. Are y'all, do you have monitoring available to the development teams, or is it mostly just the production team,
Mostly production.
Cool. Yeah, I think it's newer to get it's just a trend starting at Liquibase to start pushing that kind of visibility access to those reports back into developers' hands earlier. So it's probably new for everybody. It'll be interesting to see how it plays out.
Mm-hmm.
Well, thank you for that. Jimmy, do you have any ideas or thoughts, feedback? Either Jimmy's still muted or he ran off to go grab something to drink. All right, I'll check with the last two people here. Artur, did you have any feedback or ideas or thoughts for us? Also joining Jimmy for a drink. And Yeshas, just want to check in with you.
Hi, Kevin. So my company, we are in a stage where we are about to integrate Liquibase into our infrastructure. So I was just curious to know how Liquibase works with other tools. Honestly, this was the first time I'm hearing about DBmarlin. So it's been interesting to know how Liquibase works with DBmarlin.
Excellent. Well, I'm glad it was helpful. And I think y'all are in the same time zone. Y'all are all in the UK. So if you have questions for the DBmarlin team, they should be really easy to contact.
Sure. Thank you.
Great. All right. I think that was it. Anybody have any other questions for us before we?
Can I ask a follow-up question to Yeshas?
Yes.
You said integrating with other tools. Are there specific tools that you're interested in hearing more about how we integrate with?
Well, at the moment, we haven't even integrated Liquibase. So we have a workshop with them, in fact, tomorrow. So we'll be, I'm a DBA in the company, so I'm helping them with the integration. So maybe down the line, at the moment, we don't have any plans. I believe I'm new to the company myself. So yeah, further down the line, maybe.
Cool. Okay.
Yep. Thank you.
We are always interested in feedback from people, and we have lots of channels for communication for that. So just reach out and let us know if you have questions or ideas or any of that. And I'm going to go over the idea board here in a second too. Let me share my screen again. All right, so we have a couple of product announcements and community announcements. 4.11 or 4.11, depending on who you ask, is gone to release. So you can update to that version if you'd like. And we had 4 new contributors on this release, so we wanted to recognize them. You can always check that in the GitHub release notes. It shows who all of the contributors were, and I always like to check that out. We do have an idea board. It will be linked in the description of the video. And Karen, if you wouldn't mind providing that link in the chat for everybody. This is a great way for you to submit ideas, make suggestions, all of that stuff, and to look and see what other people have suggested and vote for those things so that we can get an idea of what the community wants. And then we have our top forum supporters of the month, and we have a couple of them on this call, so that's always fun. We appreciate everybody in the community so much, and I am loving it every day, even more. Every time I log in and I go and look and see what everybody's doing. We have a great community here, and I appreciate the help that everyone gives. So just want to recognize that. We are hiring. We have like 12 open positions on the website currently. So these are what we've got. If you're interested in any of those, go to liquibase.com/careers and check that out. We also have our Legends program, which is just a kind of like a progress tracking reward system. So the more you interact in the community, the more points you earn and the higher levels you earn in title. So I'm excited because I made leader. That was my most recent title change. So, and you can get points for all kinds of stuff if you go take a look at that on our website. Like I said, I will put all the links in the description for the different places that we are. We have our own forum. We're on Stack Overflow. We're on GitHub. We have a Discord. So you can find us in lots of places. And we appreciate you coming. We are going to have an Ask Me Anything for July. So bring your questions, anything that you come across, your thoughts, ideas, all of that good stuff. Does anybody have any other questions or comments? Nope. Well, I want to say thank you to Russ and Mick for coming and doing this, and for Andre to come and share his experience with using DBmarlin with Liquibase. So we appreciate all of you. I will have the new meetup up very soon after this meeting, so you can go sign up if you want to come again next month. But I appreciate you all. Thank you for coming.
Thank you, Tabby.
Thanks, everyone.
Thank you.
Thanks, everyone. Bye.